We will start this lesson by describing the controls and indications on the main electrical power panel on the flight deck. First, identify the location of the panel. The main electrical power panel comprises the controls and indicators for the DC power generation. We will begin with these controls. The left-hand maintenance panel also contains a selector and indicators to check DC generation. 3 push buttons control the DC sources, 2 push buttons for DC generators 1 and 2, and the external power push button. The 2 DC generator push buttons on the panel control the respective accessory gearbox-driven DC generators. The push buttons display fault annunciations and off annunciations. Currently, both push buttons are depressed. Both engines are running and the associated generators are in operation. Both generator contactors are closed and the system is supplied with DC current. Note that both push buttons are blank. Now select the left-hand push button to off and note the operation of the contactor. When the push button is selected off, the white off light illuminates and the associated generator contactor opens. Note that in this situation, DC bus 1 would automatically be supplied by DC generator 2 through the bus transfer contactor, BTC. The push-button fault light illuminates and CCAS is triggered if a protection trip is initiated by the associated generator control unit, GCU. In this case, power is automatically supplied to the affected DC bus by the functioning generator. Before considering the operation of the BTC in more detail, we shall describe some of the characteristics of the starter generators. Now, locate the starter generator. The starter generators are rated at 12 kilowatts, 400 amps, for normal operation. The starter generator functions as a starter until 45% NH and as a generator at more than 61.5% NH. Each starter generator supplies its respective DC bus. The 2 DC buses can be coupled by the bus transfer contactor, BTC. The guarded bus transfer contactor, BTC, push button controls the BTC. When the push button is depressed in normal operation, there is no annunciation and the bus power control unit, BPCU, automatically controls the BTC. Furthermore, in normal operation, the BTC is open and both DC systems are isolated from each other. When the BTC push button is released, the BTC is opened and the isolation light illuminates. Now, depress the push button. With the isolation light illuminated, both systems are isolated in all circumstances. The BTC is automatically closed and the flow bar is illuminated under the following conditions. When external power is in operation, during engine starting in hotel mode, or in the case of single generator operation. DC external power can supply the electrical system via the DC external power receptacle located on the forward right-hand side of the fuselage. DC external power is supplied to both DC buses via the external power contactor directly to DC bus 1 and via the BTC to DC bus 2. Note that the DC system operates in the same way whatever source is supplying it, starter generator or external power. The external power push button has two annunciations. The avail light illuminates green when external DC power is connected and all power parameters are correct, as they are at the moment. The on light illuminates when the push button is depressed, provided that the avail light is illuminated. With external power connected, the BTC is automatically closed. The flow bar in the BTC push button illuminates and both DC buses are supplied. The generator control units, GCUs, and the bus power control unit, BPCU, monitor and protect the DC electrical system. They are both located in the 90 VU. The GCUs control and monitor their respective DC starter generator and perform the tasks listed on the screen. The GCUs monitor the status of their respective generators and determine the annunciations appearing in the DC generator push buttons. The BPCU is located between the GCUs. It monitors and governs them according to pilot selection and system status. It also controls the BTC and the external power contactor. It determines the annunciation in the external power push button, and it controls load shedding, which we shall look at next. Now we will consider an example of the function of the BPCU. Currently, external power is supplying the system. Both generators are also operating. External power has priority over the generators. When external power is switched off, the BPCU ensures supply by switching it to the generators. Now, switch external power off. When external power is disconnected from the system, the BPCU automatically switches supply to the generators, thus ensuring that DC buses 1 and 2 are online. Notice also that the annunciations in the external power and BTC push buttons have extinguished. The avail light extinguishes when the GPU is disconnected. Before going on to look at DC accumulation, try these questions. What annunciations would you expect to see on the electrical panel given the current configuration of the schematic? Which of the highlighted components controls the illumination of the avail and on lights in the external power push button? At what percentage NH does the DC starter generator come online? Which of the highlighted components has the highest priority in DC current supply? Next we shall consider DC accumulation. In this segment we shall describe the batteries and their associated controls. Both batteries are located in the avionics rack, ATVU. Before going on to describe the batteries, can you remember the characteristics of the main battery? The principal characteristics of both batteries are shown on the left of the screen. Next we shall consider the 3-position battery toggle switch on the panel. The 3 positions are off, on and override. With the battery switch in the off position, the electrical system is switched off. With the battery as the only source of power, the main battery supplies the DC essential bus, the DC standby bus, and static inverter 1. The emergency battery supplies the DC emergency bus. When other sources of power are available and the battery switch is on, this power supply charges the batteries. We will consider the override position of the switch later in this unit in the lesson dealing with a dual DC generator failure. The main battery has 3 functions. It provides power if both starter generators fail. It provides power for engine starting. And it provides power for the electrical feathering pump. The emergency battery provides emergency power and can operate alone if the main battery is drained. It also supplies sensitive circuits, such as the avionics circuits during engine starting. Each battery is controlled and protected by its respective Battery Protection Unit, BPU, located in the 90VU. The battery charger push buttons also control the operation of the batteries via the respective battery charger contactors. The batteries are charged as follows. The emergency battery is charged by DC bus 1, and the main battery is charged by DC bus 2. The emergency supply arrows illuminate to indicate that the batteries are supplying the system. The right-hand arrow indicates that the main battery is supplying the DC essential bus, and the left-hand arrow indicates that the emergency battery is supplying the DC emergency bus. The battery charger contactor is closed when the battery charger push button is on in normal operation. The contactor opens automatically, controlled by the BPU, if there is a thermal runaway, if there is an undervoltage on the main DC bus and the voltage falls below 25 volts, during an engine start sequence, or when there is an override signal from the battery switch. Now select the emergency battery charger push button to off. When the push button is released to the off position, the off light illuminates and the respective contactor is opened. The battery charger fault light illuminates and CCAS is activated if a fault occurs. The DC ammeter in the center of the panel indicates the charge or discharge current of the emergency battery or the main battery, depending on the position of the battery selector switch. The ammeter shows discharge on the left-hand side of the scale and charge on the right-hand side. Next we will consider DC distribution. There are 11 buses in the DC system. The two main buses, DC buses 1 and 2, are supplied by their respective generators. In this case, generator 1 has failed. Which component ensures that DC bus 1 remains automatically powered? The BTC automatically ensures that the DC bus on the side of the failed generator is powered by the opposite generator. What indication is shown in the BTC push button when the contactor is closed? The illuminated avail light in the external power push button indicates that the GPU is connected and that the electrical supply parameters are correct. Now, power the system with external power. When external power is supplied to the system, the blue on light illuminates in the push button. Both DC buses are supplied. The DC service bus is always supplied when external power is connected and the attendant panel ground service push button is depressed. It is supplied by DC bus 1 if DC bus 1 is powered. When external power is selected on, DC bus 1 supplies the DC service bus. Now switch external power on. The DC service bus is controlled from the flight deck by the DC service utility bus push button. Next we shall consider the two utility buses. These buses are connected to their respective DC buses and controlled by this push button. Next we shall consider the DC service utility bus push button. Currently, the DC service utility bus push button is in the normal depressed position, and both DC utility buses and the DC service bus are powered on condition that the BPCU has not provided a shed signal. When the BPCU detects a shed condition, the shed light illuminates amber and CCAS is activated. At least one utility bus is disconnected from the associated DC bus. Now select the push button to off. Note the operation of the relevant bus contactors. When the push button is released, off is enunciated and utility buses 1 and 2 and the DC service bus are depowered. In normal operation, the battery buses are supplied by their respective DC bus, and they supply their respective battery during the charging phase. Next, we will look at supply to the DC emergency, essential and standby buses under normal supply conditions, in this case with external power connected. Normally, the DC emergency bus is supplied by the hot emergency battery bus. In the event of a battery charger fault, it is supplied by DC bus 1, and in the event of an undervoltage on DC bus 1, it is supplied by DC bus 2. Now select DC bus 1 to simulate a battery charger failure. DC bus 1 now supplies the DC emergency bus. The DC essential bus is normally supplied by the hot main battery bus. In the event of a battery charger fault, it is supplied by DC bus 1. And in the event of an undervoltage on DC bus 1, it is supplied by DC bus 2. In battery-only operation, with the battery toggle switch in the on position, the DC standby bus is connected to the hot main battery bus. It is connected to the hot emergency battery bus during the starting sequence, and remains connected after startup. When DC bus 1 is not powered, the emergency battery is no longer charged. The DC emergency bus and the DC standby bus are powered by DC bus 2. If both generators fail, DC buses 1 and 2 are not powered, and the battery-only power situation is in effect. The DC standby bus is powered by the hot main battery bus. Next we shall describe the ground handling bus. This bus is powered by either the main battery via the hot main battery bus or by external power. It supplies DC loads for servicing on the ground with the battery switch off, and it is depowered in flight since the loads it supplies are not required. The ground handling bus is powered in the following circumstances: when the cover of the cargo door control panel is opened, when the refueling panel door is opened, when entrance lighting is switched on, and finally, when the DC auxiliary hydraulic pump at the pedestal is switched on manually. When the ground handling bus is supplied by the hot main battery bus, a red light illuminates in the cargo door control panel. Finally, in this lesson we will describe the electrical system controls and indicators located on the maintenance panels. A rotary selector on the left-hand maintenance panel enables various parameters to be displayed on the 2 DC and 3 AC indicators. The DC indicators display DC voltage and DC load. The AC indicators display inverter load, frequency, and voltage. The rotary selector positions are external power, generator 1, generator 2, inverter 1, inverter 2, main battery, and emergency battery. Also, on the left-hand maintenance panel, there are byte indicators for the DC service and utility buses and for the DC standby bus. The byte indicators appear when a contactor failure has been detected. The DC feeder's overheat panel is located on the right-hand maintenance panel. DC current is fed to the DC system through 2 nickel-plated aluminium feeders. A differential temperature sensor compares temperatures between the 2 feeders. If one feeder breaks, it cools down, and the sensor triggers the magnetic byte indication. In this case, if the aircraft is on the ground, the affected DC generator is automatically disconnected from the system. The test button enables both feeders to be checked. When it is depressed, both magnetic indicators appear, indicating the integrity of the feeder overheat device.